My name is Fred Riviance. I'm the chair of the statistics department here at MSU. And it's my honor to say a few introductory words about Tapabrata Maiti, who is a professor and graduate director in the Department of Statistics and Probability here at MSU on the occasion of his investiture as MSU Foundation Professor. Among friends and colleagues, he goes by TAPS. However, he is certainly Maiti. Though I've only had the pleasure of knowing him well since my arrival here a little more a year ago, it's clear that his impact on our department and our university has been decisive since his arrival in 2008, and his positive influence can be expected to continue. Dr. Maiti hails from the state of West Bengal in India. It's probably soon to be known as Bengal as well. He received his Ph.D. from the University of Kalyani while he was working at the Indian Statistical Institute in nearby Kolkata. As a grad student, he worked on the theory of statistical inference and finite population sampling. It's a technique which applies to any large-scale scientific data collection process. Drawing on experiences as a postdoc at the Harvard Medical School in his early career, his work expanded to hierarchical models and associated Bayesian inference, what we call Bayesian inference, which he applied to public health and government policy research on pediatric cancers and later to machine learning for cancer detection and disease cluster detection and climate change. He is currently invested in high-dimensional statistics and many other things, and he's building, in high-dimensional stat, he's building computational predictive models which can assimilate image and observational data. There are many other things that TAPS has been doing, and it's very, very difficult to go through the whole list. His interdisciplinary work reaches far and wide, including collaborations at MSU with engineers, radiologists, neuroscientists, physicists, marketing scholars, and medical professionals. And I'm proud to say that despite our very distinct backgrounds, I count myself as an active research collaborator of TAPS's. We're working on a Bayesian uncertainty quantification question with nuclear theorists from MSU's Facility for Rare Isotope Beams, as Professor Kirkpatrick mentioned a little while ago. And so maybe a few words about his later part of his career before he came to MSU. His career took him to the University of Lincoln, Nebraska at Lincoln, and then to Iowa State University, and then he arrived here. His internationally recognized work has led to professional stints and memberships in various learned societies throughout the world, and again, the list is too long to go through, including, I should mention, serving as a research fellow at the Indian Statistical Institute in Kolkata, senior research fellow at the U.S. Census Bureau, special government employee at the U.S. Environmental Protection Agency, and various academic positions in a number of countries, including Australia, China, Portugal, the UK. And he is also a fellow of the American Statistical Association and the Institute of Mathematical Statistics. And I should add that being fellow in those two societies simultaneously is not that common, even for fellows of one of them. His research is characterized by a unique combination of skills and expertises, resulting in peer-reviewed publications in a wide spectrum of scientific outlets. He is well-funded by awards from the National Science Foundation, National Institutes of Health, and the USDA National Resources Conservation Service. Back in our department here at STT, we call it, here at MSU, we're very proud and indeed we're indebted to TAPS for his work in expanding the department's graduate programs. He has advised about 20 Ph.D. students, and he continues strongly. He has been instrumental in developing MSU's MS program in business analytics. And as our world enters the age of data, I easily envision Dr. Taps Maiti leading MSU's charge in expanding graduate education and research in data science. The recognition of MSU Foundation Professor is prestigious and rightly so. Congratulations, mighty professor. You're up.
Right. Thank you, Frederick. Thanks, everybody. I don't have really many fancy pictures, movies, although I'm involved with some of this stuff, whatever you have already seen. I guess instead of going to the boring mathematical modeling to you guys, possibly I should be also touching base with broader community what I do here and what I'm going to do in next few years. That's possibly I'll try to touch base. Well, as you can see, my title of the talk is not really technical. A statistician at the junction of big data and data science. So I'll definitely touch these three things: statistician, big data, data science. So I think that's the kind of the significant move for me from Hawkeye to Spartan. Certainly, it was a good move. I have to say it because my family is pretty happy here. My wife got another degree from College of Education. My daughter is growing up here happily. So it was a good move. And the department, particularly the Michigan Statistics Probability and the Michigan State accepted me, welcomed me very well. I still remember the meeting with Dean Kirkpatrick, very first day. It was scheduled to be half an hour, but it went about an hour, and department thought, what this guy is doing? But it was a lovely conversation. After coming here immediately in 2008, things are happening as I expected. In this phase of my career, I became the fellow of American Statistical Association, the world's largest organization in statistics. Became the fellow of Institute of Mathematical Statistics. I played major role for expanding research and education, different school on campus, including the business analytics. And of course, I had already collaborations with almost all the schools, except possibly I have to say the music or some of the thing. I don't know how to play the music. So here is the current things, definitely what's lately happening, which we are very excited about, particularly the department. Myself already mentioned that we have been collaborating with FRIB, and hopefully we can be key member pretty soon. This project has started just a year ago with some of the scientists over there. Among other things, there are many things, but I like to mention a couple of things. One is you know that neuroscience. This is another area where big data, data science is going to play a big role, and I have been already collaborating with scientists on this campus, where they are generating a huge amount of image data every day. And one of the objectives what I do here is you take this image and then put into your statistical machine and try to predict, suppose a mild Alzheimer's disease patient, how soon he's going to be completely Alzheimer's, or how long he's going to be intact in that stage. So some of these complicated things we have been, it's a very complicated, difficult problem, not only from scientific perspective, also from the statistical perspective, because we haven't seen this huge data before. The other important thing or exciting thing I have been doing with the College of Engineering, some of the mechanical engineers who are developing the model for different organ of our body, like heart, lung, and use thousands of differential equations. They have these computer programs which can run over the day or even 12 days. And they can predict the condition of your heart without even looking the patient. But here is the things coming in. When the patient come in, usually you have some images done immediately in the clinic. Then can we combine the computer model and the image and quickly come up to some recommendation to the medical doctor that what's going to happen in next 1 hour or so. So one objective is to first convert that highly complicated, thousands differential equations into a simplistic statistical models where the doctor can at least understand. So that is one of the things going on, and recently it has been funded by NIH U01, part of the collaboration with University of Michigan. So that's there. And all that good? This was me, I think, a few years ago, and now see me how I am. So, but I feel good. It's good, all good. As I said that I need to definitely going to talk a little bit about the future, particularly the future of statistics and this campus, the role of statisticians. And in personally, I think that this is a very good time to be a statistician. As many of you heard about that data scientist, this is one of the sexiest jobs in this 21st century. And it is obvious that there would be a big shortage for the data scientist in next few years. Here is some of the information, like McKinsey Global Institute, who kind of predicted that in 2018 there would be millions of jobs, and definitely for this type of job we need trained people. Really, anybody cannot just join. Pretty good. The student's average salary is over 100,000, and it was the #1 job in 2016. But what is data science? If you just Google it, there would be number of different versions. Here is one version from Wikipedia, but clearly from this picture, one can see that this is interdisciplinary science, but statistics is everywhere. You can see basically in the the statistics, math, machine learning also combined with the stat, all sorts of things are there. But it's an emerging field. Already there are 500 programs. Sometimes the programs' names are different, like data science, business analytics, predictive analytics, computational statistics, depending on the strength on campus, whatever we have. But what I'm going to put that some of my observations and my outlook along the things, what's happening in this community. So essentially, it is a balancing between 3 major pillars: statistics, computer science, and information management. And of course, there will be all specializations. Already I mentioned neuroscientists, health scientists, everybody would be together. And quantitative background, such as basic training in statistics, mathematics, computer science, definitely is needed. And there would be 3 pillars very quickly. There are statistical foundations, there would be computer science foundations, and essentially we will be just like this. We started like this way, human being, but now we are with the computer. In front of the computer will be like that. So that's the kind of my future I can see in that way. And information science foundations, that is another pillar which certainly statisticians are not very well equipped. We need to do those part. And here is the relation between scientists and data science and statistics. So I like this definition that a data scientist is someone who is better at statistics than any software engineer, and better at software engineer than any statistician. So clearly I'm not also saying that statistics is data science or data science is statistics, but we are in between. As I said, that American Statistical Association is the world's largest professional organizations in statistics, and they have some definition and some way how to work for the data science. And we acknowledge that data science is just not statistics, but certainly statistics is going to play a major role. And in my personal opinion, it is not a threat, it is our opportunity to work with all other scientists, just not with ourselves. And it might help to grow all 3 different disciplines: computer science, mathematics, information management, along with many other sub-disciplines, would be helpful if we can really dig into the in details and work together. Of course, for statisticians, we have much thing to do. As you can see, the average statistician is just plain mean. Again, I didn't put that thing. So.
Is that a camembert or what is that?
I don't know. So it is very, very important that we get engaged with computer scientists, database scientists, and we do the distributed computing, all sorts of things. We develop the new tools where the existing statistical methods can be imported or transported to this comfortable way, all these other things. And of course, there is an associated thing is the big data that we have to dig in. And now, so I just mentioned data science, statistics. Now, what is the relationship with big data? In general way, that's again, no concrete definitions, but it is so huge that simple, my laptop, I cannot deal with these things. I need probably some kind of supercomputer to deal this big data. But what is the relation with big data? That's what I need to, I'll just mention. But here is the big data potential. And just to be brief, to get the idea about the big data, if you bond all the data created in just one day onto DVDs, you could stack them on top of each other and reach to the moon twice. At the moment, less than 0.5% of all data ever analyzed and used. So we are generating data much faster than how much we know even. And here is the situation essentially. We have this type of gigantic data, but we know a little bit. But most difficult is that which part we need to know. Always, how do I know that this is the part will be floating above the water? That's very difficult to know. And that's where the data science and big data coming in. At the beginning, this is the cartoon I like, kind of Mickey Mouse cartoon. So this is the big data. He thinks that, oh, the data science, you don't know. I'm so big, I can just grab you. But after a while, when we learn this big data, we can say that this is the part of your body is good. This is the part your brain is here. If I can identify all these things using my tools, particularly the statistical tools, then we can become the friend, that big data science and big data becomes the friend together. Otherwise, there is no hope. So essentially what we have to do, we have to learn what is inside of the big data. And again, as you know that we don't need to know everything, but it is much more important which part we need to know. Even it's a small part, which part we need to know. So that's a very important thing. These are the these are the things which are generating big data every day: e-commerce, imaging, social media, medical records, satellite data, government records. And some of the application of the big data going very fast way, like all the search engines, image recognitions, fraud detections. Mostly I am involved in image recognition situations. This next thing is coming, self-driving cars, which will generate millions of data immediately in every second. So we have to analyze all these things. And the world is ready, every schools, everybody is getting prepared to deal with big data using these three pillars: statistics, computer science, and information science. So certainly there is a future. And where are we? We are the Spartan. So I'd like to thank you, Michigan State, and we are there.